So welcome to the first session. Here, I'm very happy to announce Susanne Kaiser with her talk, Architecture for Flow with Wardley Mapping, DDD, and Team Topologies. Thank you.
Thank you so much. Is this working? Oh yeah, it's working. Thank you so much for attending this talk about Architecture for Flow with Wardley Mapping, Domain-Driven Design, and Team Topologies. So most initiatives that try to change or optimize the system are usually directed at improving parts taken separately. So they tend to focus on local optimization of the separate parts of the system. But from a system thinking lens, local optimization of separate parts will not improve the performance of the whole. Dr. Russell Eckhoff, one of the pioneers of the system thinking movement, stated that a system is more than the sum of its parts, it's a product of their interactions. The way parts fit together determines the performance of a system, not on how they perform taken separately. He also claimed if the systemic nature of an organization or system is ignored, their efforts of improving or changing that system are doomed to failure. So when building systems in general, we are facing the challenges between building the right thing and building the thing right. Building the right thing addresses effectiveness and addresses questions such as how aligned is our solutions to our users and business needs? Are we generating value for our customers? Have we understood the problem and do we share a common understanding? Building the thing right, on the other hand, focuses on efficiency, for example, efficiency of our software engineering practices. And it's not only crucial to generate value for our customers, but also being able to deliver that value to our customers. And how fast can we deliver changes, and how fast and easy can we make a change effective to adapt to new circumstances? So the one does not go without the other, but as Dr. Russell Eckhoff pointed out, doing the wrong thing right is not nearly as good as doing the right thing wrong. So by considering the whole and having effectiveness and efficiency in mind to build the right thing right, we need a holistic perspective to build adaptive systems. And one approach out of many I would like to share with you today is combining the three perspectives of business strategy with Wardley Mapping, software design and architecture with domain-driven design, and team organization with team topologies in order to design, build, and evolve adaptive socio-technical systems that are optimized for fast flow of change. So let's start directly with an example, and let's put these three perspectives together by evolving a legacy system. And we are using a fictitious online school example as a foundation based on a legacy system built, run, and supported by functional silo teams. And the first step to evolve our legacy system is by starting with the team and analyzing their current situation in regards to team cognitive load and potential delivery bottlenecks. So due to handover, the functional silo teams reported about a high communication and coordination effort between teams when implementing and releasing changes. Dealing with a monolithic big ball of mud with a messy model and fuzzy boundaries led to high team cognitive load and tight change coupling. It takes a high amount of effort to understand a piece of code. And the teams also reported that there exist no clear ownership boundaries. So the teams were facing delivery bottlenecks impeding the software delivery performance. Due to on-premises infrastructure, the operational activity consists of configuration, backup and recovery mechanisms, maintenance, including upgrades and security updates, monitoring, scaling, and so on. So the infrastructure teams were facing a high level of operational efforts. But as a reminder from system thinking, if we plan to locally optimize only separate parts of the system, that will not improve the performance of the whole. Improving the performance of the whole requires to tackle the situation from a broader perspective and also understand the environment an organization is operating and competing in. And this brings us to a Wardley map, visualizing the landscape of an organization. So a Wardley map is part of Wardley Mapping. So who of you have heard of Wardley Mapping before? A few hands up, that's awesome, so great, a few hands are up. So a Wardley map is part of Wardley Mapping. It was invented by Simon Wardley, I guess, 15 years ago. And Wardley Mapping helps to design and evolve effective business strategies based on situational awareness and movement. And so let's create first, for evolving our legacy system, our online school example, let's create a Wardley map for our example and visualize the landscape of our online school at the current state. So Wardley map itself is composed of a y-axis and an x-axis, and the y-axis represents the value chain. To derive the value chain, it starts with identifying your users first, and your users could be your customers, your shareholders, business partners, internal users, and so on. And to derive a value chain, it starts with, so in our example, we are focusing on the teachers and the students, junior students, as the users of our online school. The next step is to derive then the user needs that the users have, and the user needs are reflecting the problems that they would like to get solved, and the user needs are the subject area for which we build a product. In our case, the teachers would like to create course content, planning a class, helping the students during their studies, and also evaluate the students' learning progress. And the students, they would like to study courses, requesting and receiving help, and also receiving evaluation feedback. And both needs to sign up and sign in as well. And the user needs and the users and the user needs, they are reflecting the anchor of our map that all subsequent components relate to. Next, we are identifying the components that are fulfilling the user needs either directly or indirectly by facilitating other components in that value chain and determining their position and dependency in that value chain. So at the top of our value chain, we have those components that are most visible to our users, where our users are touching our system, and at the bottom it gets more and more invisible to the users. So the component right now at this current state that our teachers and users are interacting, students are interacting directly with, is at the current state the online school component. It's located at the top of our value chain. And at this current state, we are dealing with a monolithic big ball of mud as one single component that we are going to decompose later into smaller parts when we come to the domain-driven design perspective. And this online school component is depending on other components, for example, infrastructure components such as search engine, data storage, message broker, SMTP server, compute platform, which is depending on a virtual machine component. So they are less visible to the users, and they are located further down the value chain. Now, each of these components are going to be plotted along the evolution axis going from left to right. So at left we have Genesis with brand new things, then custom build, then product and rental such as off-the-shelf products or open source software solutions, and then commodity on the right spectrum. And for determining the stage of evolution, let's look at the characteristics of the evolution stages. So as the components evolve through the evolution stages, there are characteristic changes from an uncharted domain and where we are dealing with an uncertain, unpredictable, rare, constantly changing, poorly understood domain. And while the components evolve through the evolution stages, it becomes more and more industrialized, more stable, more mature, widespread, commonly understood and ordered. And we can use these characteristics per evolution stage to determine the evolution state for our components in our value chain. So the online school component is representing a volatile component that is changing frequently and providing competitive advantage. So that shall go into custom build at the current state. And the more stable, mature, widespread infrastructure components, they can go then into the product and rental or commodity and utility evolution stage. And for each evolution stage, we can apply appropriate methods. That where we're coming to the doctrinal principles of Wardley Mapping, and the doctrinal principles describe universal principles that can be applied to every industry regardless of their context. And applying doctrinal principles enables an organization to respond to changes quickly, to be able to absorb changes gracefully. And so Simon Wardley has compiled a list of 40 different doctrinal principles, and one of this is, can you still hear me? Yeah. Okay, and one of this is using appropriate methods per evolution stage. So,
can you turn on your screen display settings because you cannot see the first word? Sorry.
uh-oh. Because my mouse is somewhere in the, let me see.
Can you just mention the first word so we can
That means applying doctrinal principles. Because otherwise it takes...
If it's okay for you, otherwise...
Is it okay for you? I will then... sorry. It says applying doctrinal principles.
It's for the recording, it's for each slide.
Yeah. I have to make a decision. Yeah. Are you fine with it? So I'm valuing the audience right now more than the... Okay, awesome, thank you. So, using appropriate methods per evolution states is one of the doctrinal principles, and this means that we should build components in Genesis and custom build in-house with preferably agile methods, or using off-the-shelf products or open source software solutions for components in product and rental with preferably lean methods, or outsource components in commodity to utility suppliers, or using preferably Six Sigma methods. Coming back to our online school and applying the doctrinal principles of using appropriate methods per evolution stage, that means that we are developing our online school component in-house. And for the infrastructure components, such as search engine, message broker, data storage, and so on, we are using open source software solutions at the current state. And the virtual machine component is provided as an off-the-shelf product at the moment from a service provider. And we are going to use this map as a foundation for future discussions on how to evolve our legacy system. So let's go back to the team perspective that we started first with. So to optimize for a fast flow of change from a team perspective requires to avoid functional silo teams with handover. Instead, we need to aim for cross-functional autonomous teams that are responsible for designing, developing, testing, deploying, operating their systems they are responsible for. We need to avoid handover so that work is never handed off to another team, and we should aim for small, long-lived teams as the norm. And the teams should own the system or subsystem they are responsible for, so they need to have end-to-end responsibility to achieve fast flow. We also need to minimize the team's cognitive load, because if the team's cognitive load is largely exceeded, it can become a delivery bottleneck, leading to delays and quality issues and so on. And while the communication within a team is highly desired, we have to restrict a high communication and coordination effort between teams to enable fast flow. And that's where we come to team topologies, where team topologies can help us with the well-defined team types and the well-defined interaction modes. So who of you have read the book Team Topology from Matthew Skelt and Manuel Paich? A few hands are coming up, awesome. So the cross-functional autonomous stream-aligned teams, they are aligned to a continuous stream of work, and they are focusing on a fast flow of changes. To be able to focus on a fast flow of changes and to be able to produce a steady flow of feature deliveries, they need to have the support from other teams, for example, from the platform teams. And the platform teams, they support the stream-aligned teams delivering their work and are responsible for platforms that the stream-aligned teams can easily consume. So the platform can vary in its level of abstraction. So at a lower level, a platform can abstract away infrastructure, cross-cutting networking capabilities. And at a higher level of abstraction, it can abstract away a design system or, for example, a data platform and so on. And the platform teams, they provide internal self-service services and tools for using that platform they are responsible for. Or the stream-aligned teams can get support from the enabling team, and the enabling teams, they help the stream-aligned teams to identify and acquire missing capabilities. Or the streamline teams can get support from the complicated subsystem teams that are an optional team type, and they support the streamline teams on particularly complicated subsystems requiring very specialized knowledge. And all of them are aiming to increase the autonomy and the team's cognitive load of the streamline teams to enable a fast flow of change at the end. So that is the common goal of all team types, to enable a fast flow of change. But to arrange these teams in these team types is not enough to become effective. How they are interacting with each other and when to change the team interaction is also very crucial for organizational effectiveness. So with collaboration, teams are working very closely together over a limited period of time. And it's suitable, for example, for rapid discovery and innovation, for example, when exploring new technologies. But collaboration is meant to short-live. It should not go ongoing. Should not be an ongoing collaboration over a long period of time. X as a service suits well when one team would need a code library, a component, an API, a platform that can be effectively provided as a service by another team. And it works best where predictable delivery is needed. Facilitation, this is the interaction mode that comes into play when one team would benefit from active help from another team. And this interaction mode is typical for enabling teams. So this combination of this well-defined team types and this well-defined interaction modes, that promotes organizational effectiveness and also helps us to apply some of the Wardley doctrinal principles. As a reminder, the doctrinal principles enables us to be able to respond to changes quickly. So let's now start with our architecture for flow. And we are using this previously created Wardley map as a foundation to evolve our legacy system. And architecture for flow, or optimizing a system for flow, requires to know where the most important changes in our system occur. These are the streams of changes. And the type of streams can vary in every organization. They can range from task, role, activity, geography, customer segment-oriented stream types. So in the current online school example, we are focusing on the activity streams represented by the user needs of our Wardley map. So the user needs of creating course content, planning a class, helping our students, these are good candidates for streams of changes. So they need to be focused on when we are optimizing our system for a fast flow of change. And the users and the user needs not only represent the anchor of our map, as I mentioned in the beginning, but also represent the problem domain in regards to domain-driven design. And understanding our problem domain and distilling it into smaller parts, the subdomain, can then be the next step. And that's where we come to the other perspective of domain-driven design. And domain-driven design is about designing software based on domain models, first proposed by Eric Evans. I guess you already know this book, right? Some people are not nodding. So it took me 4 times to read through this book, to be honest. So domain-driven design comes with the core statement, in order to build better software, we have to align its software design to the business domain, to the business needs, and to the business strategy. And while we are applying domain-driven design, we are also automatically applying some of the Wardley doctrinal principles automatically. And domain-driven design comes with strategic and tactic patterns and practices. So in the problem domain, we are distilling the problem domain, in the problem space of strategic design, we are distilling the problem domain into smaller parts, the subdomains. But not all subdomains are equal. Some are more valuable to the business than others, so we have different types of subdomains, such as core, supporting, and generic. And the core domain, that is the essential part of our system, providing competitive advantage. So it should be hard for competitors to copy or imitate, and supposed to be quite complex and tend to change frequently. So that's the part of our system. The core domains are the part of our system that we have to strategically invest in most, and that's where we have put the most development effort. So this should go into the genesis or custom build evolution stage. The supporting subdomains, they help to support the core domains. They provide no competitive advantage. They tend to be simpler than the core domains and tend to change less frequently than the core domains. And if possible, we should look out for using or buying off-the-shelf products or using open source software solutions. If this is not possible, if we then it goes into product and rental evolution stage. If this is not possible, if we need to custom build the supporting subdomains, we should be aware that we should not put so much development effort in that part because it does not provide competitive advantage. And the generic subdomains, these are subdomains that many business systems have. For example, authentication or payment. So they aren't core, they provide no competitive advantage, but businesses cannot work without them. So they are generally complex, but already solved by someone else. And so buying off-the-shelf products or using outsourcing to utility suppliers should be applied for the generic subdomains. So these different subdomain types gives us an idea or an indication where to invest the most development effort into our system, into the core domains that provide competitive advantage. So coming back to our online school. So in regards to our online school, the user needs of creating course content, planning a class, learning support, and studying courses, they fall into the resort of our core domains, providing competitive advantage and leading to a high level of differentiation. So they embody complexity and tend to change frequently and are not widespread in any other business system because these are our differentiators. So it is the core domain that we want to strategically invest in most and where we have the most opportunity for innovation. On the other hand, the evaluation of student progress and learning does not necessarily provide competitive advantage, but it supports the teacher's experience and is necessary for our organization to succeed. They tend to be less complex and change less frequently compared to our core domains, and we should not invest too much into that part of our system because it does not provide competitive advantage. The user needs of signing in and signing up, these are embodying user needs of generic subdomains. So the many business systems need authentication and registration. So they are widespread, standard, and expected with a high level of ubiquity and a high level of stability. So they are not core, provide no competitive advantage, but without registration, without authentication, our system would not work securely. So they are generally complex but already solved by someone else. So there exist several solutions on the market already, and there's no need for innovation here. Next, we can switch to the solution space of strategic design. So far we have identified our streams of changes, we have analyzed our problem domain, split it into smaller parts, subdomains, and also identified our core domain providing competitive advantage. Now we are switching to the solution space, how to implement it in our software. And that's where we can decompose our monolithic big ball of mud with a messy model and no fuzzy boundaries into modular components, our bounded contexts. And a subdomain contains, in an ideal case, 1 to more bounded contexts. And a bounded context forms a boundary around a domain model. So it defines where a single domain model can be applied, where a single domain model lives in. And it also indicates good themes to split our system apart and can also provide different types of boundaries. For example, they serve very well as ownership boundaries, what I will address in a second. And they also form a unit of purpose, mastery, and autonomy. And designing bounded context and domain models that usually involves close collaboration between domain experts and development teams, and to gain a common understanding, a shared understanding of our domain, because we have to understand our problem first, the domain first, before we can implement a solution. And there are different techniques available. I guess that's like event storming, domain storytelling, user story mapping, and so on, impact mapping, that are going to be handled today and tomorrow also within this conference. And you can also experience those here as well. So let's say we have closely collaborated with our domain experts and the development teams, and we have designed our bounded context. So the bounded context of content creation, course studies, class management, and learning support, they fulfill the core domain-related user needs. So they are strategically important and require the most development effort. So they go into the custom-built evolution stage and are built in-house. And the bounded context of student evaluation and notification handling, they belong to supporting subdomains. So there might exist several solutions on the market already. However, the team decided that a higher level of specialization is needed and to custom build it, but they must be aware that it should not, that they should not put too much of a development effort in that part of the system, because it does not provide competitive advantage. And the identity and access management bounded context, they belong to generic subdomains. There exist several solutions on the market already, and it should go either in product and rental and commodity and utility evolution stage. So next is architecting for flow is finding suitable team boundaries. And that's, we come back to our bounded context as well, because as I mentioned earlier, bounded contexts serve very well as suitable team boundaries. And so they are indicating good themes to split our system apart, but also work as suitable team boundaries for our streamlined teams. Another aspect to consider, as I mentioned earlier, when optimizing our system for fast flow of change, is to optimize our team cognitive load, because, as I mentioned earlier, if it's largely exceeded, it can become a delivery bottleneck. And to optimize the team cognitive load, we have to limit the size, the number and complexity of software systems that our teams are working with. And this brings us back to the evolution stages of a Wardley map. According to the characteristics of our Wardley map, the further left a bounded context or a component in general is located on our Wardley map, the higher the level of uncertainty is, which requires practices on exploration and discovery. So a component located on the left in Genesis tend to change far more frequently than components in Genesis and commodity on the right spectrum of our Wardley map. And for components in commodity on the right spectrum, we can draw on best practices leading to a clear path to action. And each evolution stage can address different practices for the related path to action, ranging from best, good, emerging, and novel practices. And the more unclear the path to action is on the left spectrum, the higher the level of team cognitive load might be. And this means that a single team can own more or larger components residing on the right spectrum of our Wardley map towards commodity than components that are located on the left spectrum on our Wardley map towards Genesis. So we have to keep the level of uncertainty, the rate of change, and also the clarity of path to action in mind when we are managing the team cognitive load of our teams. Another aspect for optimizing team cognitive load is to establish clear ownership boundaries. And this means that for clear responsibility boundaries, we need to assign a single bounded context to only one team. We should not share bounded contexts across teams, because that would diffuse their ownership. However, one team can own several bounded contexts, so that is possible. And the next step for architecting for flow is to identifying the services that are needed to support a reliable flow of changes. And this brings the focus to the infrastructure components in product and rental and commodity and utility. In order to be able to focus on a fast flow of changes, the streamline teams, they rely on platform teams providing an easily consumable platform as a service. And the platform itself, that shall reflect a thinnest viable platform that is just big enough to fulfill the needs of our consumers and should not become bigger than needed. And it could start, the thinnest viable platform, that could start with documentation, with standards, with best practices, templates, and can evolve later into a digital platform with self-service services and tools that can then be consumed by the other teams as well. And we also need to mind the dependencies and communication bandwidth between teams. So are we encountering bottlenecks or coupled teams, so they need to be eliminated? And also, another aspect that we have to consider for architecture for flow is identifying capability gaps and helping teams to acquire missing capabilities. That is then the responsibility of our enabling teams. So the first draft for our considering the previous consideration, so the first draft of our team constellation might look like in illustrated here. So in general, most teams in an organization should be autonomous, cross-functional, streamlined teams. And in our case, in our solution, very simple solution, the 4 core domain-related bounded contexts, they could, for example, residing in custom build, they could be split among three streamline teams. And the supporting and generic subdomain-related bounded contexts, they can be handled by another streamline team, and the infrastructure component can be handled by one or more platform teams. Speaking of the platform teams, let's switch now to the platform team perspective and derive their corresponding value stream or value chain. So far we have created a value chain addressing the external users, the teachers and the junior students. When deriving the value chain from a platform team's perspective, we are switching to the streamline teams as the internal users of the services that the platform team provide. And the streamline teams, they have the user needs of building and testing, releasing, deploying, monitoring and operating, and provisioning also the infrastructure of the services that the streamline teams are responsible for. And to fulfill these user needs of the streamline teams, the platform teams can provide a variety of XaaS services to support them in delivering their work. For example, a pipeline as a service supports the streamline team to build, test, release, and deploy their services. And it could build on top of various other components and capabilities, such as a version control system or a CI/CD pipeline with build server test automation and so on. To operate and monitor a service, the streamline teams, they require dashboards, alert mechanisms, observability capabilities such as log management, metrics handling, distributed tracing. And these capabilities can be provided by a platform team as a monitoring as a service. Platform as a service enables streamline teams to provision the runtime environment for their services, including the components that their services needs at runtime as well, such as database, search engine, message broker, and so on. And let's now blend in the enabling team perspective and addressing then the streamline teams and the platform teams as their internal users. So the cross-functional autonomous streamline teams, they need to cover a wide range of capabilities, such as software design and architecture, application security, user experience and accessibility, testing and QA, software development, and so on. So that's a lot to cover for the stream-aligned teams, right? So, and they can get support from specialists of the enabling team that can support these stream-aligned teams, identifying and bridging the capability gaps of the stream-aligned teams so that the stream-aligned teams can get self-sufficient at the end. And the enabling teams, they can coach the stream-aligned teams in various areas on demand. For example, they can coach them how to, what about the best practices of automated testing, for example. But also the enabling teams can also facilitate the platform teams by coaching them about what is important to achieve a good developer experience. How to design a good API, or how to write good documentation. Plus, the enabling team can coach the stream-aligned and platform teams about skills that are related to effective communication and improvement of practices such as team coaching, mentoring, process improvement, and product management. So let's go back to the online school example from the value stream, or from the value chain, from the Wardley map, focusing the teachers and the junior students as the external users. So before we are going now into the transition and implementation phase, we also need to mind potential efficiency gaps. So we want to avoid building or evolving our system based on inefficiencies, because also inefficiencies would impede our fast flow of changes, would impede our software delivery performance. So, and if the evolution stages of the components that we are using in our organization differ from the ones that are available in the market as commodity, as an equivalent, we might encounter efficiency gap. For example, if we are using custom-built components in-house, and there exists an equivalent in the market as commodity, we are lagging behind, and we encounter an efficiency gap. And this is specifically crucial if our competitors are building their value chains on top of more evolved components, because they have the benefit of increased efficiencies and also increased software delivery performance. And the bigger the gap, the less efficient an organization might be. So closing that efficiency gap is very crucial. And so, for example, in our online school example, we can close this efficiency gap by migrating on-premises infrastructure components to cloud-hosted services that we are going to address in a second. So, at this moment, we have not transitioned anything yet. We just did architecture and design consideration, but we have not touched any code yet. We have not refactored anything yet. We have not reorganized any teams yet. So now the question arises how to transition and implement flow optimization, how to go from A to B. Implementing flow optimization in our example involves a team-first approach through dynamic reteaming and an evolution of team topologies interaction modes, supporting and executing cloud migration strategy. So to close the previously mentioned efficiency gaps, we are going to focus on the infrastructure components first. And our plan is to migrate the on-premises infrastructure components to on-premise infrastructure, to cloud-hosted services. And since we are focusing on the infrastructure components first, we are starting this migration journey with forming the platform team first, from members of the previous back-end and infrastructure teams. So we are following a team-first approach. This new platforms team is then starting the cloud migration journey and is working on the side with the freedom to learn, explore, discuss, discovery, and assess possible cloud migration strategies. It determines a migration path and its new platform. And in this example of our online school, they are starting with the replatforming cloud strategy. And with replatforming, we are modifying the underlying infrastructure components by replacing on-premises infrastructure components to cloud-hosted services, while we keep the applications architecture the same at this moment. And we can replatform the on-premise infrastructure components incrementally, step by step. So, and with replatforming, we are then offloading the management of infrastructure components to the cloud provider, and also reducing our operational efforts on our side, and also improve the performance, stability, and elasticity of our infrastructure. Once the on-premise infrastructure has been fully migrated to the cloud provider through replatforming, the remaining infrastructure team can then merge into the previously formed platform team as one single team, and can split later into separate teams if this is applicable. So far, we have replatformed our infrastructure component to cloud-hosted services, but we also would like to modernize our monolithic big ball of mud and eliminate its related bottlenecks. And this brings us to the next level of cloud migration by refactoring our applications architecture. And refactoring applications architecture usually involves to split apart our applications architecture into smaller parts. And in the online school example, we want to incrementally decompose on our monolithic big ball of mud by decompose it into our previously designed bounded contexts. As I mentioned, bounded contexts, they are indicating good seams to split a system apart. And to start the refactoring journey, we are doing a team-first approach again. And to start the refactoring journey, we are forming the first streamline teams from members of the front-end and the back-end teams. In the meantime, the remaining front-end and back-end teams, they can merge into a temporary joint team, which takes care of the remaining monoliths, because it still exists, right? We still have our monoliths running. So, and this joint team can then take care of this monolith as long as it does exist, as one single team with no handover involved, and can then, from there, split later into separate streamline teams, which I'll address in a second. So let's go back to the first form streamline team, and they would like to kick off the refactoring journey. And it's supported by an evolution of team topologies interaction modes. So at the beginning, the streamline teams the first form streamline team can closely collaborate with the first form platform team from the beginning, and they can jointly discover and assess potential cloud options that are applicable to the bounded context that the new streamline team is responsible for. And the streamline team might decide to refactor their bounded context using serverless technologies. As soon as potential options have been discovered and knowledge was shared, the interaction between platform and streamline teams can go into limited collaboration and limited facilitation, going from daily interaction to on-demand interaction, occasional on-demand interaction. And this can evolve later to an X as a service once the serverless ecosystem is more established in the organization, and where the platform team can then provide best practices, standards, tools, APIs to easily consume the platform they are responsible for. As a next step, the previously merged joint team that took care of the monolithic big ball of mud at the beginning or in the meantime, they can split then in the next streamline team going on their refactoring journey. And this new formed streamline team and their refactoring journey can get support through an evolution of team topologies as well. So they can get support from the previous streamline team and platform team during their cloud journey. So they can suggest, the platform team can suggest possible cloud options that are applicable for the bounded context that the new streamline team is responsible for. They can coach them how to use the CI/CD pipeline in a serverless ecosystem, and they can also point to the platform as a service it has established before and incorporate their feedback while they're using it. And the first formed streamline teams can also coach and facilitate the new formed streamline teams in sharing their knowledge, and also coach them, for example, how to implement a serverless function in a hexagonal architecture, for example. And from there, the next stream-aligned teams can form and go on their refactoring journey, and also receive then active help from the previous teams that have formed previously during their cloud journey, so that at the end, we have refactored our monolithic big ball of mud into modular bounded contexts based on serverless technologies through a team-first approach by dynamic reteaming and an evolution of team topologies interaction modes. And have optimized our previous system for fast flow of change. And this brings us to the end. So the combination of Wardley Mapping, domain-driven design, and team topologies helps us to understand the environment an organization is operating and competing in. It helps us to gain domain knowledge and discovering our core domain, providing competitive advantage. It helps us to know what components to build in-house, where to buy or use off-the-shelf products or use open-source software solutions, and where to outsource to utility suppliers. It helps us to decompose our problem domain into modular components, the bounded context. It helps us to align our teams and evolving their interactions to the system we build and the strategy we are planning. It helps us to identify potential efficiency gaps and eliminate bottlenecks and increasing our software delivery performance so that we as an organization are able to respond to changes quickly and absorb changes gracefully. So the combination of Wardley Mapping, domain-driven design, and team topologies provides, in my humble opinion, a great, holistic, powerful tool set to design, build, and evolve adaptive socio-technical systems that are optimized for a fast flow of change with a focus on improving the performance of a system as a whole. And there is a few resources that I've compiled together that gives you the opportunity to dive into that topic. And also, one of the authors of learning domain-driven design is also giving a talk tomorrow and also do a book raffle. So please appear in numbers. And yes, there's also coming a book out next year, hopefully, if combining even more perspective, also like how to have context mapping in place. Michael Plöth is talking about this during this conference as well. So how to avoid tight change coupling between the bounded context that has a lot of other areas involved in that one as well. And with that, thank you so much for your attention, and I'm looking forward to your questions in the hallway. Thank you.